I want to introduce to you the panel moderator, Dick Schaap, Managing Director at MARIS, and Dick is also the technical coordinator of the Blue Cloud project. As he has already mentioned, he's involved, he has a long-lasting experience in coordinating many national and European projects related to data infrastructures, like the Sea Data Cloud project, the EMODnet ingestion portal, and you will hear more from Dick.
Thank you, Sarah, for introducing. Yes, I'm from the Netherlands, and the Netherlands is close to the sea. That means that since I was born, I was always interested in the sea, and I want to play with the sea, more or less. So I became a coastal engineer, and started in the government in the Rijkswaterstaat in the Netherlands, North Sea Directorate. And there again, there was one big playground. We had everything. We had ships, we had underwater things, we had a plane, everything. So it was just one small unit, and I had to do an area 10 times the size of the Netherlands, which was great, of course, for me. And over time, I got more and more interested in data with operational networks, oceanographic networks. We had some platforms at sea. We also worked together with the oil and gas industry, by the way, by using their platforms to collecting data and sharing data with each other, already in the 80s. And over time, I became more and more interested in data management, and that's why we started a project called MARIS, and MARIS over time became privatized. We started the foundation to make it a wider project. And I got very interested in the European arena from the 80s on. And that means that I have done more than 25 years of working on the European research infrastructures and on European data management systems. We have a nice panel today, and we have also a challenging title, How to Unlock the Potential of Data Towards a Global Blue Cloud. And that will be, let's say, the leading line for the panel. And I would like to invite our panel members to the podium to join me. And we have quite a good company. So I'd like to ask Jan-Bart Calewaert to come forward. Jan-Bart is working at the EMODnet Secretariat. We have Lisa Clough. She's working at the National Science Foundation. We have Wim Hugo. Wim is now, I think, partly retired, but he's still very active, and he is quite an expert in South Africa and the data management. We have Alan Kenchington from the Fisheries and Oceans in Canada. We have Luiz Moutinho. He's from AORAC-SA. Sorry for not spelling right. And we have Janice Trotte, and she's from the Brazilian Navy. That's what I picked up. And I would like to start with asking each of you, let's say, to introduce yourself, a little bit your background and your, let's say, maybe the present project you're working in, for about 2 minutes. And maybe Janice, would you like to start? Ladies first.
I'll be pleased to. Good morning, ladies and gentlemen. For those of you that I still did not have the pleasure to meet, as said, I'm Janice Watts. I presently work at the Brazilian Navy. I have quite a history, according to my age, of experience in international grounds. I've served at the Intergovernmental Oceanographic Commission in my past days. And I have been responsible for the first national oceanographic data center in Brazil. That's back to the 90s when I started this, what I call challenge of gathering data into one center. And I'm just talking about Brazil. I'm not talking about the globality of our main challenge here. One of the issues that I have experienced in Brazil is the impediments that legislation could bring to post, but in fact, much more than governments, the oil industry, as has just been said, is the real impediment to progress as we see it these days down there. Some of you may have heard about a major oil spill that we just had in Brazil. And yet, Petrobras was not there to help with their data. But thanks to international cooperation, we got lots of support from our distinguished colleagues from France, Mercator, some people from Italy. So we do benefit from international collaboration. And I think this is the bottom line that I wish to leave here in this session, is that we should pursue our endeavor of having healthy oceans, and to do so, we do need to think on a more pragmatic way. And what I would like to leave to our colleagues to discuss further is what sort of events should we concentrate to show the value of the blue cloud, for instance. So that's more or less my message. Thank you.
Very clear. José Luiz, can I ask you to introduce yourself?
Hello, good morning, everybody. My name is José Moutinho. I'm the Chief Business and Networking Officer of the Atlantic International Research Center. It's a collaboration network that started about 2 years ago as a scientific diplomacy initiative from Portugal, but now there is about 16 countries involved in Africa, South America, Europe, and we engage in the US through universities such as MIT, Penn State, and other universities. And as a collaboration network, we noticed that there's a lot of lack of data, below, the equator. And for most of people living in Europe, equator means Gibraltar Strait. Several times I've been in meetings where they say, for example, that Cape Verde, we have representatives from Cape Verde over here, in South Atlantic. It is not, And why I'm saying that, there's a huge lack of in situ data in this area. Brazil, of course, in South Africa, there's a lot of initiatives in this area, very interesting initiative, but the rest of the Atlantic is basically a huge gap of information. And I'm not even more important related to coastal areas. And when we start to talking about not, open sea, but coastal is really a completely void. Again, going back to what we discussed in Cape Verde in some of the workshops, for example, there's a lot of investment of models and gathering data from the ocean around Cape Verde for these global models, but zero information about the coasts of Cape Verde. So we try to create this idea of the air data net, where the countries such as Cape Verde, São Tomé and Príncipe, Angola could process images, run some basic algorithms, store data, because it's still a challenge. I won't say which country it was, but we've been involved on some projects that when we arrived there to discuss data, they didn't have electricity in the university for 3 days. So before talking about this fantastic blue cloud, it's fantastic, we'd really like to participate. We are dealing with a very basic, no connectivity, no data. And most important of all is we'd like to bring to this discussion is the local coastal and ocean needs. What we've been developing in this area is a lot of workshops around. The first one and most important one was in Cape Verde for 2 days. Some of the people over here, like Joaquin, was there to lead this workshop. And we understood that what people want is not what projects like Blue Cloud deliver. I know most of these projects like Blue Cloud, I'm not saying specific about Blue Cloud.
Can I ask you to conclude?
Yeah, just, it's only on the supply side of information.
We have a lot of questions.
Yeah, sorry about that. Yes, I will conclude. Okay. And we are doing it with the user need perspective. Thank you.
Okay. Very engaged, for sure. Ellen, can I ask you to introduce yourself and some background in the domain?
Good morning, everybody, and thank you very much for inviting me to participate on this panel. I'm a research scientist with the Canadian Department of Fisheries and Oceans, based at the Bedford Institute of Oceanography in Halifax, Nova Scotia. And our department is one of the largest data collectors for the Northwest Atlantic, both in terms of oceanographic data, fisheries data, and so on. Much of the data we collect is actually, to get the most out of it, you have to know the collection structure, so the stratification schemes and so on, to really be able to get the most from this data. And in the question time, I hope to be able to give you some information on some of the initiatives we're doing to make that more accessible to Blue Cloud and others. I'm not an IT specialist. I'm here representing the research community, both as an end user and potentially a data provider. And access to reliable and accurate ocean data is really important for addressing basin scale and even global questions. But as a researcher, your level of discomfort increases as you have to rely and trust the data provided by others. And so it's really important that the data that's put on these kinds of platforms is really well quality controlled, that it's understood the error and other issues associated with it. If it's model data, that alternative models are available, because nothing can kill the credibility of a project faster than having a research upload the data and say, this doesn't make any sense, and then compare it with some other data and run into a whole series of issues there. So it's really great that this project and others are actually going to engage with the research community. And through some of the projects I have been involved with, you've heard about Atlas and also Sponges, Horizon 2020 projects that have collected information on BMEs and other data types from the North Atlantic, that we can build on that experience. And also I'm involved in iAtlantic, which is a project that's just started going forward. Murray Roberts has already introduced it to you a little bit. And it's very well integrated with this Blue Cloud initiative. And in fact, iAtlantic is working with EMODnet to develop these fair open access GIS tools for the whole Atlantic, north and south. And Kate Larkin, who's with Seascape Belgium, and her colleagues, she's actually involved in all three initiatives. So I'm really hopeful that the iAtlantic data collection process and that building on that from the earlier Horizon projects will get well integrated into the Blue Cloud system. I just wanted to lastly mention that I participated in the UN Decade of Ocean Science North Atlantic Regional Workshop in Halifax a couple of weeks ago. And not surprisingly, there's lots of parallels with what you're doing here. I think probably you were well represented and maybe guiding the discussion on the data there. But they're really hoping to create what they're calling Atlantic 5D, which is taking 4D data and adding new data relevant to different communities, for example, fisheries data, perhaps data on infrastructure, surge risk exposure, and so on, economics, and putting it into your digital twin world to actually test scenarios and so on. So I'm really happy to see this. And one thing that hasn't been mentioned, we mentioned it earlier, is that in addition to FAIR, the UN Decade will include concepts of CARE, which is collective benefit, authority to control, responsibility, and ethics. And this is really important for industrial data and absorbing that, but also for traditional knowledge data and the ethics there, issue particularly in Canada and the North. So I think if we can maybe think about CARE as well as FAIR, that will help us going forward. But, yeah, but that's sort of where I'm coming from, and look forward to discussion.
Can I ask Dean? I think
So as Dick mentioned, I was the Chief Information Officer for the South African Environmental Observation Network until December or so. And hope to be out of this trip again in a month or two. My background is in chemical engineering, but I started focusing on systems engineering, consulting work, and systems years ago. Worked at the consulting industry and joined SAEON 10 years ago because it was the project execution. During that time, we built up a team of 55 people. Aspects of research making. I think what one has to focus on, in addition to FAIR and CARE, they said from acronym, that we can add to that, and that is trust. I'm still involved terrestrial and the world data system, and I think the concept of a trusted digital repository that diminishes the risk for future reuse of data is quite important in the context of that. I'm still involved in ILTER, the International Long-Term Ecological Research Network, as the chair of the International Long-Term Committee, so maybe add a little bit to
Okay. Lisa, Clough.
I'm Lisa. I'm with the U.S. National Science Foundation in the Oceans Division. I also can speak a little bit to what's going on with biology initiatives. I want to pick up on data.
Jan-Bart, Calewaert.
Thank you. So good morning, everybody. My name is Jan-Bart Calewaert. I'm the head of the Secretariat of the European Marine Observation and Data Network, EMODnet, since 2013. But EMODnet already exists a bit longer. It's now almost 10 years old. It started in 2009, and we're celebrating this year our 10 years anniversary. So with EMODnet, I think in those last 10 years we came a long way. We converted a very fragmented European marine data landscape into an interoperable data sharing framework. We built EMODnet together with 120 organizations around Europe working together to identify and assemble marine data sets which were stored and scattered around Europe in different data systems. And we've done it collectively, working a lot on the interoperability. It's very multidisciplinary as well. So over the course of 10 years, we are now becoming very operational, fully operational, providing access to data and data products to set thematic data portals. We provide data products such as the pan-European bathymetry, the digital bathymetry, and the broad-scale seabed habitat map. And I think it really serves as an example of how you can build on existing initiatives across different countries, federating these different systems into a joint service. And that can serve as an example also in federating with other infrastructures and other data, complementary data initiatives. And also be scaled up as we increasingly work at the European level in the Blue Cloud and other initiatives also across the Atlantic with iAtlantic project and the Atlas project. And all of these are these technical data systems. So,
Okay, I'll go to the panel. First of all, I'd like to say a little bit more about the Blue Cloud itself, because the title of the panel is Towards a Global Blue Cloud, but first must have a very good idea on what is a global blue cloud before we can discuss these items. And that's why I want to give you some thoughts, let's say, about the Blue Cloud itself. Because as we already mentioned, say only in Europe we did an estimate, and we estimated we spent about 1.4 billion a year to collect data from the ocean and from the seas. So that's quite a lot of data, and a lot of money being spent. And that's being done by research, but it's also of course done by authorities that need it for the management of the territories, for the EEZs and coastal protection and other things. And of course also by industry, because industry, as we also learned, because industry operates activities and supports also a lot of these activities, and you need a lot of data. together 1.4 billion, which is just an estimate, but it gives you the size. It also means that, say from the ground up, of course, there are already long-lasting data in management infrastructures, centers, and, let's say companies and research institutes that have good databases. But then in the, let's say, starting in the 90s, we started with already building some European infrastructures, say more pan-European, to make better use of all those scattered and dispersed data points, and also to get some more harmonization. And over time, let's say what we built was a couple of, let's call it major infrastructures. AORAC is one of them. Since 2008, we had CDataNet. We started in the 90s. And we also have the Copernicus network, say, which is more from the satellite point of view. So you take the satellites and you make, and also products based on satellite images and models. And those are, say, a couple of these, let's call it powerhouses in the European landscape for marine data management. And the interesting thing is that with the Blue Cloud, in fact, we came together with also others, which are more in the biological domain and then also in the genomic domain. And we said, hey, we share a vision. The vision is that if we bring together all these resources, but also not only our resources in data, but also more and more, let's say, algorithms and analytical applications, and also bring that together and, let's say, and then have the access to large computing facilities for high performance computing or big analytical processors, make it much more open for the scientists so they can do workflows and work with this data in a multidisciplinary session. That means that we then can really get much more answers to our problems, let's say, to our challenges, our scientific challenges. And of course, as already said, there is the, let's say, the data goes to information, information goes to knowledge, and knowledge goes to policy. That means that the knowledge we generate by such a process is, of course, supporting the policy and also the policy measures and the policy implementation, effective management and the governance of our seas. And that's the idea, let's say, behind the Blue Cloud. So we said, let's have a couple of these big players in the European field. And each of them already has a big network of constituents, operational networks, research institutes, vessels, everything, let's say, all the equipment you can think of is being used, but their data is flowing to those infrastructures, and on those infrastructures together, that let's make a cloud of this. And also involve then the, let's say, the players, the users, the researchers, but not only researchers, but also affect society, because it must be a cloud which is open to the whole society. It's not only for the researchers. But researchers will have a major playground. That was the idea, and Blue Cloud started then as a combining computing resources, multiplicity data, and algorithms. And that is undertaken by those big parties, the blue data infrastructures, but also we brought into the equation, we brought in the E-infrastructures, let's say the horizontal, the computing centers, which are in Europe UDAT, we have D4Science, and we also have DIAS, which is a major constellation. And they are more or less, will provide the platform on which we will build. And what we will build is partly a discovery and access system, to be able to discover all the data available in those different blue data infrastructures and the products available. But the other part is to make use of that data in a virtual research environment. That means a place where you can do workflows and do analytical runs, use high computing resources, which is also in line with the EOS thought. But the Blue Cloud goes further than EOS, because it's also the society center. It's let's say the blue is also the blue economy and the blue environment. It's not only the science. We have to make sure that, let's say, we are a big stakeholder, but we are in fact catering or serving more stakeholders in the world than just the science. That's to be and that means that we have then the VRE, and in this virtual research environment, let's say this is a conceptual idea. Also, it's an initial Blue Cloud, because it's a project's only 3 years, so we work with what we have and we will demonstrate that we can do it. And for that purpose, we have 5 excellent demonstrators, which bring together the excellent science, bring together multidisciplinary data from different domains, but also bring together, let's say, or are serving certain society challenges. And we use that to, in fact, to provide the evidence that the concept can work. And if it works, we like to spin it out, let's say, to a larger framework over time. And for that purpose, we also do, we are working on a roadmap to have a lot of stakeholder involvement, a lot of engagement from users, learning from them, and this way try to map the way forward to make a real Blue Cloud over time. And this is what I'm only talking about Europe, and that's why it's so interesting that we are now talking, let's say, on an international level, because I would like to, of course, learn from you if there are comparable initiatives going on in the other regions, and how you might provide opportunities or see opportunities to play with us. Therefore, we have provided prepared some questions. I would like to start with the first question, and I think those of you who said, of course, I would like to hear from everybody of you, but it might be that somebody says, I want to answer first, and the others then follow. And also you get ideas when you listen to somebody else. I know as an experienced panel member. First question, are there initiatives similar to the Blue Cloud in your regions? Who would like to start here? Ellen.
Okay, I'll jump in. So we heard a lot about the OOS projects from the earlier speakers, and in Canada we have the Canadian equivalent. And although I'm not intimately involved with that, I think there are others present here, perhaps in the room, I'm not sure, but certainly Brad DeYoung with the AtlantOS has been involved. And it's called the Canadian Integrated Ocean Observer System, and Fisheries and Oceans Canada is a supporter of that financially. And what they're hoping to do is federate the Canadian data much the same way that you're trying to do here. And the CEOS project is going to, has 3 regional nodes, I guess you could call it, one for the Atlantic, one for the Pacific, and one for the Gulf of St. Lawrence. And I think it's just starting up now. They do have a plan for their cloud environment with, I think it's an industry created company called Compute Canada, but where I think it's certainly the partners in Compute Canada are all the major universities in Canada, and so that's where the actual infrastructure will be held to run the cloud. But the data provision and so on will be coordinated through these regional centers. And so I think that's probably the most relevant activity that you should connect with. And is there anyone here working with that? This is the lady to talk to for more details. Okay, so I'm happy to introduce. Nice to meet you. And she can give you those technical details that you would like. Thank you.
Thank you very much. Somebody else? Janice?
Thank you. Well, the answer to your question is very simple. No, there isn't. Okay. But what I think would be an interesting idea, if I may, is to find out whether there are similar initiatives elsewhere in this all-Atlantic scenario we work on. Mm-hmm. So if I may propose, let's start challenging AORA and AANChOR to provide a first answer to that, and then let's move forward.
I think we are already making inventory right now.
Well,
we don't have to wait for that.
You think that's going to be enough?
No, I want to hear first the other panel members to see if there's more coming before we point to somebody else. Okay. Yeah. Lisa? Lisa? Mm-hmm. Mm. Mm-hmm. Mm-hmm. Mm-hmm.
There really isn't that much going on with big data, in my opinion, on the IU side. They're working with data providers all over the world.
Mm-hmm.
I'm familiar with AORAC and Neon. I was just Neon network there. It is all open data and real time.
Mm-hmm.
Geography is not as much, but listening and sizing are all all of those core concepts that industry are very interested in our
Mm-hmm.
getting figures and data. I don't charge you.
Maybe that's also one of the points I say. In the US, of course, you have a very powerful industry. While in Europe, let's say, where EOS is chosen for the academic computing sector, so it's a different way to start. Because we don't have those same industry giants as you have. Of course, we make use of them every day. Okay.
Yes.
Somebody else wants to ask, but I want to also, so the NSF, you also have this CUBE project.
Yeah, so on the Earth side, we do have EarthCube, which is for all geosciences, and they are also fairly along in something called PanGeo, and in PanGeo, that is also emphasis on open data for all, but a cloud compute model where you are not getting data, you're not keeping your data, you're giving your data to the cloud, and then you're doing all your computing within the cloud.
Yeah, yeah, because that's one EarthCube, and also with Unidata and all this. Okay. Somebody else? Ellen wants to add to this? Yeah. Okay. Yeah, if others also have Wim, maybe?
Okay, yeah. I just wanted to make a quick comment about government users of the cloud. I don't know if it's a project in or a problem in Europe, but the government of Canada has been very reluctant to allow employees to access cloud environments, and it's not because of it's really the security issues associated with it. And so at the present time, we have a couple of experimental models with GIS applications being trialed. But right now, if I want to use the cloud, I have to get permission from someone called the Chief Information Officer, which is so high up that I haven't bothered. It can be a problem, and I think it could be one that you could face as well. Because I think if you want to make effective links of policy, having government scientists able to access your environment is going to be critical.
Yes, so we have, I guess, what is the equivalent of the European Open Science Cloud in South Africa, a national cyber infrastructure. It has 3 pillars, quite predictably the research network, high-performance computing, and then data storage facilities. Of those, I would say the research network is the jewel in the crown. The other 2 are not particularly let's say, user-focused at the current point in time, and a bit of a frustration. I would go as far as to say we're at the cusp of the type of country where it will be much less trouble to engage with the big cloud providers, Amazon or Google or Microsoft, and say, we'll pay you to provide a national cyber infrastructure. And provided the security and sovereignty issues can be addressed by the vendors, I think the solution will be even better for countries less developed than South Africa, because if South Africa struggles to do this, you can imagine how less developed countries in the third world will struggle to provide these services. Now, SAEON on top of this, but also providing our own physical infrastructure, has built research data infrastructure that I think is reasonably sophisticated, reasonably well funded for the long term. And we provide curation services, infrastructure, or they provide curation services, infrastructure, decision support, and systems development capacity in this offering. We have thematic initiatives, one of them being focused on shallow marine and estuary observation. And then there's talk that Southern Ocean and Antarctic observation infrastructure will also be making use of the same research data infrastructure. So not as sophisticated, not as well funded, but I think actually for a long time now, somewhat ahead of the curve in realizing that these things must be funded for the long term. And I think that's a quite important aspect that many people don't always look at.
Jan-Bart? Okay. You have something to add, or maybe reacting to the sustainable funding?
Yes, no, I think, well, as we are a very European initiative, I can mostly speak from our perspective in Europe. But I think one of the important things in Europe maybe to understand the context and why MacLeod is also a very important initiative is that in terms of funding, many of the data infrastructures that are very complementary. In Europe, we have three major ones, which is EMODnet, Copernicus Marine Environmental Monitoring Service, and SeaDataNet/Cloud. They are all funded through different mechanisms. Traditionally, SeaDataNet from the research community, research funding, DGR2D. EMODnet is a long-term marine data initiative funded through the Directorate General for Maritime Affairs and Fisheries, DG Mare. And Copernicus is supported to DG Grow. So increasingly over the last years, we've been collaborating more intensely, but with the Blue Cloud, we have a concrete project where we really can connect with concrete services. So that's the second point, that through each of these initiatives, they have evolved to an operational service, becoming ever more user and service oriented. That's also the case for EMODnet. And that's also very much the philosophy of the Blue Cloud, and that's why we are very, very happy to be part of it. And this is something that we really need to cater for, that we don't just develop access to data and services, but that we actually very much build it based on user needs. And the third point is maybe to highlight, and you mentioned it already, Dick, that we're also developing this roadmap, Blue Cloud roadmap, and this is a very open and inclusive process where we also engage beyond the research community, with industry, but also beyond Europe. And I think it's an open invitation to be involved and connect to us through building this long-term roadmap.
Just building up what was said about South Africa and emerging countries, there's a lack of infrastructure and also funding, but most importantly about capacity building. We do need, to invest in capacity building, not only collecting, but also interpreting data on these emerging countries. This is very important. And finally, I don't know any kind of initiative in the area of their center. But we have some pockets of data that are very interesting that could be somehow be linked to initiatives like Blue Cloud, mostly time-bound for projects. But it would be very interesting to know how can we link up and use the infrastructure of Blue Cloud to interpret and distribute this data.
Okay, then we have second questions, and some of you already mentioned, in fact, the answer. Was how are these initiatives supporting the global grand challenges? And then we can think of climate change. Wim, you want to start?
Yes, so this is something that is to us, or was to us, quite important and remains to me one of the big challenges. I think there is an expectation that with the availability of open data increasing, that decision and policy support will improve, but I think that's the same as they say in our country, throwing money in the air and praying.
What? Sorry? Say it again.
Throw money in the air and pray. So because we are also involved in decision and policy support, specifically for global change, risk and vulnerability assessment, and for renewable energy assessments, amongst others, we started realizing that the basic scientific research infrastructure can take variables to what we call analysis ready, where the variables have been well defined, the protocols under which they are gathered are known to everybody and publicized, there's proper metadata. In other words, it is fair. It can be accessed, it can be reused, and it's interoperable. But the semantic transformations needed to use that data to support a specific policy question is not related to the original data. It may have been for the first question asked of that data, but not of subsequent questions. So we need to separate the synthesis-ready variable states that support decisions from the analysis-ready infrastructures that provide that data, because they're never going to be the same. In a reusable universe, there are going to be many relationships between decision support environments and data providing environments that are duplicated and reduplicated all the time. So I think there's a lot of work and thinking and contextual development to be done in the world to build this bridge between the questions that are asked by the policymakers and the data offerings that are standardized and fair and made available by science.
You want to add to that, Ellen? To this workflow, this process, let's say?
Yeah, I think I can maybe build on that a bit in that there can be some very direct routes to policy changes. And I've experienced that both with the Horizon 2020 project Atlas and with the sister project Sponges. I work for, I'm on working groups within NAFO, which is a regional fisheries management organization in the Northwest Atlantic. And Atlas has produced a paper that's coming out in press this week on climate change scenarios for 6 species, including that occur on both sides of the Atlantic, corals and commercial fish. And I think it's been really a great opportunity to take that work and bring it directly into the decision making for through NAFO and also Fisheries and Oceans Canada. In Sponges, we've had a paper published a year or so ago on the connectivity using the oceanographic models between the areas that they've closed to protect vulnerable marine ecosystems, and that has gone directly into this year's review of closed areas. So there can be very direct and substantive linkages between these data collections and policy decisions. I think we're seeing the equivalent happening in Europe through ICES with the vulnerable marine ecosystem data collected there. The EU has put a call out for information on how that can be used in their decisions for protection of VME and EU waters. So some of these things can be affected quite quickly and immediately, particularly with vulnerable marine ecosystems, which are reviewed every 5 years by the UN General Assembly. So that pushes things. Others, of course, take longer, but you know, they can be developed and worked on.
I think also one of the aspects of Blue Cloud, or let's say e-infrastructure, is also that you do more with visualization and that you have much more products which are more easy to grasp. Because there's always, we always talk about the gap between science and policy, but is there really a gap? I don't know. It's more a process that you have to overcome by speaking maybe the same language, of giving them the products that they need, which they understand. And there's always people always talk about data, but data for many people is something completely different than what the scientists think of data. For them it's let's call the raw data collected in the field, while somebody else says, I want data, and they want a map. A map is not data, it's a data product. A certain level of processing already has been done. And of course now supported by much more, let's call it interactive visualization. And we also heard about this mission Earth, which is going that direction. So having a map, and on the map you can click, you can get some information, you can run some analytical processes, you can see impact analysis, these kind of things. Then of course you are bridging the gap between the science and, because these elements, all these tools have to be developed with scientists, because you have to be very aware what you're doing there, because you're not playing simply data and see what comes out of it. It has to be, let's say, trustworthy, and it has to be fair, but it's based on fair principle, but it has to be trustworthy. What's the word trust? And we have to care. Yeah.
So I care, and to build on that, maps are really important because I work sort of at that interface, operationalizing policy for the government, and maps are the product that are most useful to bridge the gap between the science and so on. But as you said, they have to be defendable maps.
Yeah. Somebody wants to pick up that?
So I think we have one case study that really is a very successful global approach on that. It's the Argo floats. So we have worked all that out on the permitting side as well. We still have a ways to go with gliders, but for Argo floats, when we go into EEZs, essentially it's like, okay, we understand what we're going to do. We just make phone calls. So I think the next gen of the Argo floats, our BGC Argos, or our biogeochemical Argos, really will take us down a road where we can start asking some of the global grand challenges, carbon and climate in particular. And I think we have an initial project with SOCOM, that the Southern Ocean Carbon and Climate BGC Argo initiative that did draw on some internationals. But I hope with BGC Argo coming to fruition in the next 5 years that'll be a really powerful tool for us to look across the grand challenges in a case study that we already understand.
Yes, I think at least in the realm of what we are doing, there are many examples that can be given both at different levels. The more operational level with EMODnet physics and biology, we are contributing to marine environmental assessment, the UN World Ocean Assessment, as well as the regional and global assessments of the IPBES, the Intergovernmental Science Policy Platform for Biodiversity and Ecosystem Services. And with these initiatives like EMODnet Biology, which is also underpinning with EuroBIS, the European component of the Ocean Biogeographic Information System, underpins also OBIS. So 20 million of the records, 20 million of the 50 million records that OBIS provides are from EuroBIS. So it's really driving a lot of the data that flows into this global system that's available also for global users. EMODnet physics, that's another model that we do to collaborate internationally, is providing its data infrastructure also to global initiatives. For example, the Southern Ocean Observing System is having its data visualized and accessible through the EMODnet physics infrastructure. This is a win-win situation because they get the infrastructure, they provide data into the system, which EMODnet physics is then able also to make available for reuse by others. And EMODnet physics is typically an example of how it's becoming much more global, because we provide access to all the Argo floats, the data there. So it has a completely global coverage. Then at a more policy, or let's say management level, we are also extending our collaborations, working on interoperability aspects bilaterally. For example, we started a new project this month, working together with the Chinese counterpart of EMODnet, which is the National Marine Information and Data Service. So we will connect EMODnet with NBIS, working on an interoperable data system, but also, and you know much more about that, Dick, on the data interoperability aspect of that, because that's a huge part of that work. And that also fits into global initiatives such as the Ocean Data Interoperability Platform, and that we're very much engaged in working. But I think we are already going into the next question on interoperability. And a very important counterpart that we are increasingly engaging with, and I think everybody does, is IODE, and the International Oceanographic Data and Information Exchange. And they've recently started a Flanders Trust Fund supported project called the Global Information Hub to support, underpin the UN Decade of Ocean Science. And we will voluntarily contribute as a European component to that. Yeah. Another opportunity to collaborate across different regions.
Okay. Thank you. José?
Yeah, one important aspect of the data is sometimes the emerging unintended use of this data, with ocean, oceanographic and atmospheric data. And I'll give you a good example. I went to São Tomé and Príncipe to discuss oceanographic and atmospheric models for the use for fisheries and aquaculture. And they loved this idea, but they said, could this data help us to manage, airborne diseases, specifically malaria, because it's a small island state, so they are, they are much worried with malaria right now. And also, could this data help us to understand how I mean, diseases that comes from all the kind of disease. For example, they have a moth that came from Gabon that destroyed the corn crops completely, destroyed completely. So it's very interesting because there is even we don't have to focus only on this metocean to solve things related to the global challenge like SDG 14, but so how could it help in small land states solve other kind of problems?
Now maybe to follow up, and just because this next question is about fairness of data, and that's in fact we of course stands for findable, accessible, interoperable, and reusable. And finding and accessing is in most cases is done, or we are very good at that. Let's say we've done a lot. But especially the interoperable and the reusable, the last one, is something that you are touching upon. Let's say the fit for purpose for other. You collect some data for something, and then somebody else available. Yeah, I say, is it possible for them to use the same data? Most cases it can't, because it's dedicated to a certain cause. And that's why we have these fairness principles that we have to add much more, let's say, metadata richness and also provenance to the data to be able to judge better what the data can mean for you. And the question is a little bit, are you aware of, let's say, are you following these principles, of course, in your regions? And also, are there some specific, some specific projects or approaches that you can think of, especially for the interoperability and the reusability? So not for finding and accessing, because that's I say, as old as the road to Rome. But that's yeah. Ellen, you have a point on this?
Yeah. So Fisheries and Oceans Canada has something called a service-oriented architecture and interoperability plan. And I went on to it, and there are really 4 categories that I think should be considered: data management and exchange standards. And we follow the IODE group that Jan-Bart mentioned. But there are also taxonomic standards and code tables, such as worms and itis, oceanographic standards and code tables, and quality control procedures and standards like the Argo Quality Control Manual. So those are the broad categories that are included in our government approach to interoperability. And I'm sure they're widely recognized by everybody in that field. But I do have the list of the ones that we follow in particular, and there's probably no surprises there.
Yep.
Thanks. So our data is fair by default, and I think the interoperability question is a major one. From a technical perspective, there are basically 3 kinds of interoperability for us. The first is syntactic, which means that we know how to address the internet to get the stuff that we want. Yeah. So a service URL, for argument's sake, that must be well defined. And then the schematic interoperability tells us what we're going to get back. Is it an image, or is it a map, or a vector file, NetCDF, all very technical. But this is not a problem because it works, and it's been working for many years, and it's really not a big issue. So the semantic interoperability, that is the third part, is the problem. And this links to reusability, simply because the more we move towards decision support, the more synthesis there is, and the more the likelihood that the data sets we will be using come from different domains, and the semantic interoperability problem becomes bigger and bigger and bigger. Whether it has a solution, I don't know, because I think, except to have an ontology of all ontologies, there is probably not a technical solution, maybe more towards artificial intelligence and some kind of machine learning to assist us with linking up data sets with different kinds of semantics across, because that's what humans do. We look at these things and we interpret the differences, and we start thinking about what to do about it.
Somebody else has an opinion?
So I think this one is very difficult if we want to embrace all of the components. Yeah. I am struck by maps and the way humans think. We actually had a speaker last week at NSF on the computer science side on big data. And their sort of big punchline was we have to get back to topologies because the general public is never going to plug things into a big data, and so let's work with artificial intelligence to get us back to maps, and we can sort of compare maps and then get to something we can do on our iPhones. So I think that yes, we can, there's a lot of challenges out there. Semantics and knowing where your partners are at is huge, but I think we should aspire to, well, how do humans learn? And we're pretty visual, and maps that we can bounce off of each other really are a good way forward on that message for knowledge for all.
I think there's also one thing that what I see in our practice is that to make something really reusable, we need much more metadata. But we don't want to ask the scientists to provide it because they get a little bit metadata wary, let's say. So we must have more and more, let's say, systems in place in the acquisition systems which already tackle that issue with sensor web technologies, with having shipboard systems, let's say, for the cruises that the scientists take. And this way we're trying to settle this, let's say, in many projects, that you get a lot of information already straight from the sensors or from the platforms that are carrying the sensors, and which then make the data, and also from the laboratories, by the way, the laboratories, of course, there's a lot of sampling taking place, and those samples go to laboratories for further digestion, curation. And this way, let's say, we get much more metadata than simply asking the human interface, let's say, to provide all this metadata, because then you don't get it, and also it's very difficult to get it in a controlled manner. Wim, you want to touch on this one?
Yeah, just a quick addition. This metadata aspect is actually very, very difficult. Not forgetting it, that is also true for the original data sets or services. But we need a consistent and standardized way to annotate the end-use applications of data in a specific context. Because we can't do machine learning if we don't record what we do, right? So if I take a data set and I aggregate it and filter it and combine it with another data set by mapping two ontologies or vocabularies to one another, I need some kind of consistent, maybe even automated way of recording what I have done so that that can serve as a basis for future machine learning.
The provenance aspect.
And let me add, I don't know if anyone from our BICO DEMO office or biochemical oceanography data management office. I think it is important, and Cindy Chandler taught me the term data sommelier. I appreciate you guys all speaking in English to make it easy, so there's my attempt. But I think that we really do need data sommeliers who will help us understand, as scientists, what pairings we should be doing. So if somebody from BICO DEMO is here, chat with them, or if you have your own data sommeliers out there, I think they're good translators.
Maybe we have 5 minutes left. Maybe there's some questions from the audience to the panel members. If you have something that you missed or you want to follow up on. Yeah? Wait for the microphone.
Thank you. It's been a fascinating discussion. I just wanted to give one quick anecdote and then actually respond to Janice's challenge, if that's okay. The anecdote is that in the Atlas project, we made a very nice collaboration with a commercial operation in Boston, Parallel Works, which allowed us to collapse the time to analyze Lagrangian particle tracks of larvae. So on an academic system, 2 weeks. With Parallel Works, it was a matter of hours, and they were extraordinarily good to work with. So that was just a quick anecdote. Now, Janice, you challenged us, I think, and we want to put a proposition from the iAtlantic community on the table that we work with GEOS, that we go beyond the boundaries of our European lens, and we work with the GEOS portal to create an all-Atlantic community site. We're working on this with EMODnet. My knowledge on this will start to be exposed very rapidly. My data manager is here, but not in the room just now. So this is put forward from the iAtlantic project to partner with GEOS. We have support from the European Space Agency to move forward with that, and we'd love to talk to others about that and to pick that discussion up tonight at the reception.
Is that a question, or is it?
It's a proposition. It's a proposition, and I'd love to get feedback and to pick it up later.
Okay.
Just to answer to your proposal very quickly, we just approved a community action at GEOS, meeting last year called AtlantOS. It's exactly in the way you just said, trying to put all these initiatives together. I'll be happy to talk to you about that later.
Janice, you say why you were.
It's just a quick add up. Firstly, to thank you for getting my challenging proposal ahead. And that's not the only one. We may have several other challenges ahead of us that would certainly help the Blue Cloud project if we think about global challenges. And if I